Hi guys, in this video we are going to be continuing on with the notes from 2.6, 2.7 on rational functions. Okay, so in the last video we went over how to find the parent function for rational functions. The parent function being f of x equals 1 over x is the most simple rational function, so therefore it's the parent function. It looks like this blue graph. The red dotted lines are our horizontal and vertical asymptotes. The graph approaches those. In this case, they do not. Vertical asymptotes are never, don't cross vertical asymptotes, but horizontal asymptotes you can. But in this case, in this graph, we do not. There will be examples down the road where we do cross the horizontal asymptote, though. Just so keep that in mind. Okay, what I want to talk about in this video at the beginning here, I'm going to go over transformations of rational functions. So our parent function being 1 over x. So in example 1, we are multiplying by 2 because 2 divided by x, if I multiply 1 over x, 1 over x times 2, you can put that over 1 and you end up with 2 over x. So we're multiplying by 2, so think about what that means for transformations. Multiplication is going to produce a vertical stretch of factor 2. So all y coordinates will be twice as big as they are for the parent function. Instead of 1, 1, it'll be 1, 2. Instead of let's see, when we put in 2 into the parent function, we got 1/2. If you double that, it's going to be 2, 1, and so on. All right, so it's a vertical stretch of factor 2. The next one here is we are taking the 1, and now we're dividing by not just x, but x plus 3. When it's in the denominator, so our function is dividing by x, and when you go when you have the x plus 3 in the denominator, that's going to be a horizontal shift, and it is going to shift the graph. It's a horizontal translation. If you say shift, that's fine, but more formally, it's a translation. 3 units, think to yourself which direction. When we add, remember horizontal is always like backwards from what we think it should seem like it should be, but we're adding 3, but it actually shifts it 3 units to the left. So in the parent function, instead of the vertical asymptote being on the y-axis, it would shift 3 units to the left, and then the whole graph would shift 3 units to the left, like that. Example 3, when you're adding a number outside, not in the denominator, but after you've done 1 over x, and then we add the 5, what that's going to do to the graph is it's going to be a vertical translation. Again, if you say vertical shift, that's fine. A vertical translation, oops, that's an N, 5 units up. And then example 4, we have quite a few different transformations here. Let's do each one at a time. That negative, what does that do to the graph? Reflects. So it'll be a reflection over the x-axis from the negative being multiplied by a negative in the front. What does the 1/2 do? The 1/2 is we're multiplying by a half, so that is going to be a vertical. Instead of a stretch, it's going to be a vertical compression this time, so everything is going to be half as tall, or the y-coordinates will be half of what they are in the parent function. So vertical compression of factor 1/2. The minus 1 in the denominator is going to shift the entire graph. It's a horizontal translation. When it's in the denominator, it's horizontal. Horizontal translation, think to yourself which way it's going to go. We're subtracting 1, so it goes 1 unit to the right. And then last but not least, we have plus 4. This plus 4, oops. There we go. Plus 4 is going to be a vertical shift or a vertical translation. Four units up. All right, so that is kind of a review of transformations and then how they work with rational functions. If you look at example 5 over here, example 5, notice that it's not just multiplying by a number or just adding a number. We actually have an extra x in the numerator, and down in the denominator we have x squared. So when you see that, it isn't just a transformation of the parent function. So it's going to have similarities to the parent function, but it is not a transformation from 1 over x. When you start seeing, oh my, that's terrible. When you start seeing extra variables, then it's not just a transformation. So not a transformation of 1 over x. All right. So I'm going to stop there for this video. In the next video, we're going to look at how asymptotes affect the end behavior and how to write those that in limit notation. So join me for the next video.